Okay, so this video is about domain and how to find the domain of a function. Now, with this type of problem, there's basically two potential factors that show up. So one thing that shows up is you have a square root sign, and that's going to affect your domain. Another thing that shows up is the potential of dividing by 0. These are both things that cannot happen in the real numbers. You cannot square root a negative number, and you cannot divide by 0. So let's deal with f of x first. It says it's square root x minus 5. Square root x minus 5. So what we do is, like a normal domain will consist of all the numbers, all of the real numbers. These are all the possible x values we could have. We could go from negative infinity to positive infinity. Now, with the square root x minus 5, we can't just pick any number on this number line because there's some of them that are going to cause us to square root a negative number, which again can't happen in the real numbers. So what we can do, though, is we can plug in the number 5. So I'm just going to put it somewhere on the number line. That's 5, right? That's okay, because the square root of 5 minus 5 is equal to the square root of 0, which is just 0. That's okay. That's awesome. That's a real output. So 5 is okay to plug in. What we want to figure out is, can I plug in numbers bigger than 5, or can I plug in numbers smaller than 5? So for example, let's see what happens if we tried to plug in over here like a number like 6, right? Okay, well 6 minus 5, let's take a square root of that. What's the square root of 6 minus 5? Well, that's just the square root of 1, which is just 1, right? It's just 1. And that's okay. It's okay to square root 1. So that means that it must be okay to plug in numbers bigger than 5, because if we plug in like 7 or 8 or 9 or 10, these are all going to end up being a positive number under the square root sign. But if we tried to plug in a number on the other side, like 4, well, that's going to give us the square root of 4 minus 5. Oh no, that's the square root of negative 1. That is not a real number. That's a complex number, so that's not in the domain of f of x. And it turns out if we plug in any number smaller than 5, that's going to lead to a negative under the square root, which means we cannot include this part in the domain. Cannot include anything smaller than 5. So we're cutting out all of that. Okay, one sec here. Okay, so like magic, it's gone. And now the only numbers we have left are 5 to infinity. Whoops, did not mean to erase that. 5 to infinity. So these are the numbers. These are the x values that we can plug into f of x and get a real output. So we would say the domain of f of x goes from 5 to infinity, which we would say, well, here's the number line, but we could say it goes like this, 5 to infinity. Or we could say x is a real number. X is a real number. Conditions, x has to be greater than or equal to 5. Okay, so pause the video if you want to take in this example. I'm about to erase everything related to the square root and talk about g of x in a second here. Okay, so for g of x, it's not like there's a bunch of numbers that are going to cause a problem. There's only one x value specifically that will lead to a non-real output, and that is x equals 2. If we plug in x equals 2, we get 1 divided by 0, which is undefined. Okay, but anything other than 2 is going to be fine. For example, plug in 5, you get 1 over 5 minus 2, which is 1/3. Plug in like negative 6, you get 1 over negative 6 minus 2, which is negative 1/8. Those are all fine. Those are real outputs. It's all good. But we can't plug in x equals 2. So if you consider your number line, here it is. We go from negative infinity, and we go to positive infinity. Okay, well, what we have to do is, if we have x equals 2 on our number line, we just have to get rid of x equals 2. So let's just say it's like right there. Okay, I guess we should like label, okay, we'll say that's 0. Okay, well, x equals 2 is excluded from our domain. So what is our domain? It's negative infinity all the way up until you hit 2, but not 2. And then 2 all the way until infinity. That's saying everything is okay except for 2. A couple ways to do that. We can say negative infinity to 2, union 2 to infinity. This is saying we're going to do the interval from negative infinity to 2 and 2 to infinity, but we're not going to include 2 as shown right here with our parenthesis in our union. Okay, so everything but 2. Another way of saying this is we can say x is a real number as long as x is not 2. It's any real number except 2. Okay, that's another way of expressing the domain of the function g of x. Okay, so now let's look at a possible example where there's a square root involved and a potential divide by 0 error involved. So again, I'm going to erase everything, so pause if you want to take in this example. Okay, so now we have a new function, square root 6 minus x divided by x squared plus 9x plus 8. okay, there's lots of red flags coming up here when we're considering the domain. We know we can't take a square root of a negative. We know we can't divide by 0. So what we're going to do is let's deal with the square root of a negative situation first, okay? So again, the number that we can plug in for sure is 6, because 6 minus 6 is 0, and the square root of 0, that's a-okay. So, okay, here's 0 on the number line. Let's say 6 is like right there. We need to decide, can we go bigger than 6, or do we have to plug in numbers smaller than 6? So, again, we can try to plug in a number bigger than 6, like, 7. And 6 minus 7 will give us a square root of negative 1. That's not okay. And if we plug in any number bigger than 6, we're going to have that same result. Okay, really quick, we can check 5. Square root of 6 minus 5 is going to give us square root of 1. And that is okay. That's equal to 1. Put equal smiley face here. So that means that we can plug in numbers smaller than 6. So we're going to erase everything bigger than 6 from our number line. Okay, so far our domain is negative infinity until 6. But we have to deal with this issue where there might be some x values that will make us divide by 0. So what we're going to do is we're going to factor x squared plus 9x plus 8. That factors is x plus 8. Oh no, I'm going to run out of space here. Okay, let's try again. Okay, let's put it down here. X plus 8 times x plus 1. Okay, so that means if we were to plug in negative 8 or negative 1, we would divide by 0, which isn't going to give us a real output. So what we have to do is we just have to eliminate negative 8 and negative 1 from our number line. So we'll just go and give us an approximate idea of where they would be. So we'll say, okay, negative 8's gone, negative 1 also gone. So then what's our domain? It's negative infinity until negative 8, union negative 8 until negative 1, union negative 1 until 6. So how we would write that? Let's write it out. Negative 8, or sorry, not negative 8. We would go negative infinity until negative 8. So negative infinity until negative 8, union negative 8 until negative 1, union negative 1, okay, until 6. And then we can be 6, so we denote that using this bracket. So we say, okay, well, we're including 6 because, again, the square root of 0, that's okay. That's a real output of 0. But we can't include negative 1 and we can't include negative 8, but we can include everything within these intervals. So, for example, a number that would be okay would be like negative 10, right? Or maybe you could plug in like between negative 8 and negative 1, that would be like negative 6. That would be okay. You could plug in negative 2. You could plug in 5.9. You could plug in 5.7. You could plug in 0. These are all numbers that will lead to real number outputs. So that is our domain. Really quick, let's look at another way to represent that. Going to do that down here. So we'll say x is a real number. All of them. Well, not all of them. We have to say that x has to be less than or equal to 6. And also x cannot be negative 8, and it can't be negative 1. So that is about as tricky as it gets in terms of our domain problems because there's really only 2 major issues that come up: can't square root a negative, can't divide by 0. So this is an example that includes both of those.